So I'm going to walk you through the steps for graphing sinusoidal functions of the phase shift form. So the first thing I want you to do when doing this is to determine the amplitude. Okay, all it is the absolute value of A, the coefficient in front of the sine or the cosine. So determine the amplitude, determine the period, T equals 2 pi over omega, and determine the phase shift. So we need amplitude, period, and phase shift. Okay, phi over omega. All right, after you get those values, step 2, you're going to determine the starting point. Of one cycle. Okay, so determine the starting point of a cycle of the graph. And so the starting point is phi divided by omega. All right, so that starting point is phi divided by omega. All right, that's that x value. All right, then you're going to determine the end point. The end point is phi divided by omega plus 2 pi omega. Okay. Next, you're going to divide the interval. Okay. So how am I going to divide up the interval? Phi omega, comma, phi omega plus 2 pi over omega into 4 equal lengths. All you do is you take 2 pi omega and you divide by 4. Okay. That tells you how far to jump each piece. All right. So use those key points to find the 5 key points, just like we did in the past for sines and cosines on the graph. Okay. Step 4, you're going to plot those 5 key points. And connect with the curve, sinusoidal curve. To obtain the graph of one cycle. After that, you can copy the cycles as many times as makes you happy. Step 5. If B is not equal to 0, then apply the vertical shift. Either up for positive B's and down for negative B's. Okay? So those are the steps, right? The steps that you work through. So let's work an actual problem here. Okay? let's take an example. So let's do find amplitude, period, and phase shift of y equals 3 sine 2x minus pi, okay, and graph the function. Now, we use the same 4 steps we used, that we just described, okay? So how do we do this first? Well, we need to get it in the form, okay? Well, what is our form here? When we look in here, we have omega x minus phi, right? So we know omega is 2. We know phi is pi. And I know my amplitude is 3. Okay? So coefficient in front of the sign, that's 3. All right? Now, I can factor out, so y equals 3 sine of, now let's factor this 2 out here, and that leaves me x. Okay, so that leaves me x minus, now if I pull a 2 out of pi, that means I got to divide by divide by 2, okay? So one way you can always check is if you distribute back in here, do you get the same thing back? And if I do, I get 2x and then minus pi, that's good. So that's the same thing, all right? So we're good to go, okay? So when I look at this, my amplitude is equal to 3. My period, okay, what was the formula for period? It was 2 pi omega. Omega was 2, so my period is pi. Okay, and therefore that's going to give me a phase shift. Phase shift is phi over omega, which is equal to pi divided by 2. Okay? So the second part, right? What does the second part tell me to do? I'm going to take the starting point of the cycle and the ending point of the cycle. So the starting point of the cycle is pi over 2. And the ending point of the cycle is what? It's phi omega plus 2 pi over omega, right? So that's equal to what? That's equal to pi over omega plus pi, right? Pi over 2 plus pi gets me what? It gets me 3 pi over 2. Okay, 3 pi over 2. Now, what do I do with this? I subdivide into 4 subintervals. All right, how do I do that? Well, I can take my number line. Okay, so pi over 2 to 3 pi over 2. So 4 looks like this. Okay, how do I get this? Well, the length of this interval here, 1 period is pi, right? So to go 1/4 of the way is 1/4 pi. So pi over 2 plus 1/4 pi is 3 pi over 4. The next one, if I add a fourth to that, I get pi over a fourth and a half and a fourth makes a whole. That's pi. Okay. And then if I add a fourth to pi, I get 5 pi over 4. Okay? So hopefully you're good to go with that. So your first value, pi over 2. Your next value, pi over 2 plus pi over 4. Your next value is pi over 2 plus pi over 4 plus pi over 4, right? Your next value is pi over 2 plus pi over 4 plus pi over 4 plus pi over 4, right? And then the last one is your pi over 2 plus pi that we got here, all right? So those points, these are critical points. Now that I have these x values, okay, I'm going to plug those in. So I use these x values to plug into my function. Well, think about what sine does. Typically, it starts at 0. It goes up, down, down, up. So my critical points look like this. Okay. Well, what do I know? Okay, what do I know? The amplitude is 3. So that means I'm going to rise up to 3 here. So I start at 0, go up to 3, then I go down to 0, and I go to -3, and I get back to 0. Those are the y values. Okay. The corresponding x values are right here. So my critical points are pi over 2 comma 0. Next one is 3 pi over 4 comma, and then what's the y value? It's 3. The next one is pi, and then what's the y value there? It's 0. This one here is 5 pi over 4, and what's the y value? It's -3. And then the last one is 3 pi over 2, and its y value is 0. Okay, so you could also get these by just simply plugging into the function. So if I took this function up here and I plugged in, I'd have 3 times the sine of 2, and then if I plug in a pi over 2 for x minus pi over 2, what does that get me? Well, that's 3 times the sine of, well, that's 0. 0 times 2 is 0. So that's 3 times the sine of 0, which is 3 times 0, which is 0. That's why I get this 0 here. Okay? And so you can play that game, and you can get the y value for each of those if that's what you want to do. Or you can just use what you know about the graph of the sine and work off of your key for your amplitudes. I think personally that's more intuitive and faster if you do it this way over here. Okay? But, you know, whatever floats your goat, right? All right. So we're going to take these points and we're going to plot them. Okay? So I need to make sure that I get pi over 2. 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2 graphed on here. And so what's going on? I start at 0, I go up to 3, down to pi, 0 again, and then down to 3, and then back to 0. So what does the curve look like? Looks like this right here. Okay. And so you can take that curve and just copy and paste like I just did there, right? You see how easy that is to copy and paste? That joke never gets old, right? And phase shift it out, okay? So as you can see, you start new periods. Your phase shift there is pi over 2, right? Your amplitude is 3, right? So that's like 3 pi over 4 comma 3. This is pi comma 0. This is 5 pi over 4 comma negative 3. And then that's 3 pi over 2 comma 0. All right, so you've got your 5 key points plotted there. That's definitely, you're going to need to be able to plot those points. Okay, hopefully that was helpful for you. Hey, let's see if we can try that using transformations. Okay, so instead of doing it that way, maybe we could see it, from a transformations point of view. So you've got the graph. So you've got the graph y equals 3 sine 2x minus pi, right? And so we came up with 3 sine, and then inside we had 2 parentheses x minus pi over 2. Okay? So what's going on here? Well, let's start out with the sine graph. So pi over 2 comma 1, pi comma 0, 3 pi over 2 comma negative 1, 2 pi comma 0, 0, 0, right? Okay, this is the y equals the sine of x. Now, what am I going to do first? Okay, first thing I'm going to do is I'm going to multiply by 3. Okay, so I'm going to multiply this thing by 3. So I have y equals 3 sine of x. Okay, so 3 times 0 is still 0. But then this amplitude here, I'm not going to be able to do as good of a job, but you get the idea. We're up now 3 points, 3 values higher, right? So magnitude of 3 in both directions. So instead of 1 to negative 1, it's 3 to negative 3. Okay? So these values here didn't change. All right? Now, that's multiplying here. That is a vertical stretch transformation. Okay, by a factor of 3. Now, what else am I doing here? Well, I'm replacing x by plugging in a 2x, right? So that's giving it a double speed. Okay? So I've got a double speed going on here. So what does that mean? That means that I get through the cycle twice as fast as I normally would. So typical cycle, typical period is 2 pi, right? But if I'm going twice as fast, 2x speed, what's that mean? then my period is going to get over in pi units in half the time. Okay? So it's a half factor, 1/2 factor. All right? So there's a horizontal compression of 1/2. So what does that mean? Now all of a sudden, my amplitude is high. Let me move this down a little bit. Okay, so it's still, going up to 3. But instead of it taking pi over 2, it's half the time of pi over 2, which is pi over 4. Okay? Instead of going from 0 to 2 pi, it goes from 0 to pi. All right, so I finished my period in half the amount of time. Okay? So instead of 3 pi over 2 down here, it's half of that, so it's 3 pi over 4. Okay, so 3 pi over 4, comma -3 down there. All right, and so right there, that's pi over 2, comma 0. All right, now this graph is y equals 3 sine of 2x. Okay? Double your speed. Now the last thing we need to do is we need to shift it. Well, it's not a shift of pi units. When we factored the 2 out here, we saw we had a phase shift. A phase shift of what? Our phase shift is pi over 2. Okay? So this phi here, or phi, whatever you want to call it, this is shifting to the right pi over 2. So we take our graph and we shift it to the right pi over 2. So we start here at pi over 2, 0. Okay, and then we get our 3 pi over 4, comma 3. And we get our other values. We get our pi 0. We get our 5 pi over 4, comma -3. And we get our 3 pi over 2, comma 0. Okay? So it's the exact same graph that you had. This is y equals 3 sine 2x minus pi. Okay? Using transformations. So you like the transformation technique? Great. Okay? If you're more of a step-by-step systematic person, take your function, factor out that coefficient in front of the variable here, make sure that you factor that out so that you can see the phase shift clearly. Start at your phase shift and add 2 pi over omega to get to the other endpoint. Then take your subinterval, divide it up into 4 equal parts, 1, 2, 3, 4. And once you have that, take those values and input them into this function here. And you get your 5 key points. Take those points if you know the general curve and plot it out. And then you got it. And then just repeat. Otherwise, you can use transformations. All right, just, whatever you do, make sure to show your steps and how you got through it. Okay?